Have you ever stumbled upon a strange substance and wondered, what in the world is this? Maybe it was a sticky residue on your kitchen counter, a peculiar odor in your basement, or an unidentified goo in your backyard. We've all been there, scratching our heads in bewilderment, desperate for answers. Fear not, my friends, for science has bestowed upon us a remarkable tool to unravel such mysteries: Gas Chromatography-Mass Spectrometry, or GCMS for short. GCMS is like having a super-powered detective at our disposal, capable of identifying even the most elusive chemicals. It's a powerful tag-team duo that can separate a complex mixture into its individual components, and then provide a unique fingerprint for each one. Talk about a dynamic duo. But GCMS isn't just for satisfying our curiosity about weird goo. Oh no, it plays a crucial role in a wide range of fields. From forensic science and environmental monitoring to food safety and drug analysis, it helps us catch criminals, protect our planet, and ensure the quality of the products we use every day. Pretty impressive, right? So, buckle up, science enthusiasts, as we delve into the fascinating world of GCMS and uncover the secrets behind this chemical sleuthing powerhouse. GCMS is our secret weapon in the fight against crime. Imagine a crime scene, shrouded in mystery. There might be traces of evidence, like paint chips, fibers, or even drugs. That's where our trusty GCMS steps in. It analyzes samples, separating chemicals and revealing the truth. It's like a microscopic magnifying glass. GCMS is also a superhero for our environment, detecting pollutants in air and water, monitoring industrial emissions and testing for pesticides. GCMS is our environmental watchdog, and a key player in medicine, analyzing blood and urine samples. It's like having a tiny chemist inside our bodies. GCMS is a true jack of all trades, a silent guardian, a chemical crusader. Now let's break down how this amazing technique works, starting with gas chromatography, or GC for short. Think of GC as a high-stakes racetrack for chemicals. The goal? To see which chemical crosses the finish line first. Imagine a starting line where we inject our mystery mixture. The track itself is a long, thin tube called a column coated with a special material. And the runners? Well, they're the different chemicals in our mixture, all eager to win the race. But here's the catch. This isn't your average sprint. It's more like an obstacle course. As the chemicals zoom through the column, they encounter different challenges that slow them down. Some chemicals are stickier than others, and tend to cling to the column's coating, while others zip right through. It's a test of speed, agility, and chemical properties. Now, how do these chemical contestants actually move through the racetrack? That's where our trusty sidekick, the carrier gas, comes in. Think of the carrier gas as a gentle breeze, guiding our chemical runners along the column. This gas, usually helium or nitrogen, flows continuously through the column, carrying our chemical mixture along with it. It's like a conveyor belt, gently pushing the chemicals forward. As the mixture travels through the column, the carrier gas ensures that the chemicals stay separated based on their speed and affinity for the coating. It's like a well-choreographed dance, with the carrier gas leading the way, and the chemicals gracefully following. By the time they reach the finish line, the chemicals are nicely spread out, ready to be identified by their unique arrival times. It's like a chemical photo finish, capturing the order in which each runner crossed the line. Once our chemical racers have crossed the finish line in the GC race, it's time for mass spectrometry, or MS, to take center stage. This is where things get really interesting. MS is like a molecular weighing machine that can identify each chemical based on its weight, or more accurately, its mass-to-charge ratio. But first, we need to give our chemical contestants a little makeover. As they enter the MS chamber, they're bombarded with a beam of electrons. This knocks off an electron from each molecule, transforming them into positively charged ions. It's like giving them a quick zap of electricity. Now our charged-up chemicals are ready for their weigh-in. They enter a special chamber called the mass analyzer, where they're subjected to electric and magnetic fields. These fields act like invisible hands, sorting the ions based on their mass-to-charge ratio. It's like a molecular sorting hat, separating the chemicals based on their weight class. As our charged chemicals navigate the mass analyzer's obstacle course, they're separated based on their mass-to-charge ratio. Lighter ions, like featherweight boxers, zip through quickly, while heavier ions, like heavyweight champions, take their time. It's a delicate balancing act between mass and charge. A detector at the end of the mass analyzer counts the number of ions at each mass-to-charge ratio. This information is plotted on a graph called a mass spectrum, which looks like a series of peaks. Each peak represents a different ion, and its position on the graph reveals its mass-to-charge ratio. This mass spectrum is like a chemical fingerprint, unique to each molecule. By comparing the spectrum of our unknown sample to a library of known spectra, we can identify the mystery chemical with remarkable accuracy. It's like matching a suspect's fingerprints to a database. Now that we understand the science behind GCMS, let's explore its incredible applications in the real world. This dynamic duo is a true crime-fighting hero, helping forensic scientists solve mysteries and bring criminals to justice. Imagine a crime scene where a mysterious substance is found. GCMS can analyze this evidence, identifying drugs, explosives, or even traces of accelerants used in arson cases. It's like having a chemical detective on the scene, piecing together the puzzle of what happened. But GCMS isn't just for catching bad guys. It's also a champion for our environment, helping us monitor air and water quality, track pollution levels, and ensure the safety of our food and water supplies. It's like having a watchful guardian protecting us from invisible threats. From identifying pesticides in our food to detecting harmful toxins in our water, GCMS plays a crucial role in keeping us safe and healthy. It's a silent protector, working tirelessly behind the scenes to safeguard our well-being. GCMS is a shining example of how science can be used to solve real-world problems and make our lives better. It's a powerful tool that allows us to see the unseen, to understand the complex chemistry of our world, and to make informed decisions about our health, safety, and environment. By unraveling the mysteries of matter, GCMS empowers us to live in a cleaner, safer, and more informed world. It's a testament to the power of human ingenuity and our relentless pursuit of knowledge. So the next time you hear about a scientific breakthrough or a new technology, remember the amazing capabilities of GCMS. It's just one example of the incredible things we can achieve when we put our minds to it. And who knows what other scientific wonders await us in the future? The possibilities are endless.